Hi everyone, this is Ishika Bhattacharjee, and today we are going to explore Python's standard library, mainly focusing on the math, statistics, and decimal modules. So these modules are going to come very handy for your programming task, as you don't have to write complex codes for any math, statistics, or decimal uh, operations. You will already be provided with these helpful modules, and you can easily make your coding very convenient. So the library's it covers basic to advanced mathematical operations. The module statistics contains the statistical analysis tools like the mean, median, variance, etc. So we don't need to code it out to get these values. And the decimal module contains the high precision arithmetic for financial or sensitive calculations. So we are going to use this later on with projects or something, and at that time, you it will be convenient for you to have these operations in your hand before. So now one thing is, what is the difference between a library and a module? You need to understand that module is a simple file containing Python codes. It may contain functions, classes, variables that we can reuse in our programs. Now, different modules or different functions put together are known as a library. So this is the normal thing, and Python provides us with some built-in modules to make our coding more easier, like these math, statistics, and decimal. And other than that, we can also make custom modules. We can write our own Python file and put it as a module and import that file in other programs to reuse that code snippet again and again it without writing it every time. Now let's dive into the math module. So I have told you that it just does the standard to advanced mathematical operations like square roots, power, factorial, trigonometry, and many more. So here I have just shown you square root function, factorial function, power function, and pi function. So you can see that this function sqrt will give me the square root of any value given inside of it. And the factorial function gives me the factorial of any value given inside of inside this function as an input. Now the PWO, the power function, gives me the power of the element written first up to that element. It is the x, it raises this value, it raises x to the power of 5. So my 2 would be raised to 2 to the power 3. Then I have the pi function, which will normally give me the pi value. Then I have the sine function that will give me the sine value of any value. So here I am getting pi by 2, since the pi value uh, uh, pi by 2 will give me a number, and when I provide sine function it gives me the sine of that number. So here the uh, I am getting the sine of 90 degrees. That's the output I have got. See, square root of 49 is 7. Factorial of 5 is 120. 2 raised to power 3 is 8. And the value of pi is given here. And the sine of 90 degrees is given here. So see, this is so easy to use. Now you don't have to write any finding square root function in your code to perform any operation. You can just import these modules in your program and just use it conveniently. Now let's just give me the explanation once again. So the sqrt function gives the square root of x. The factorial function returns the factorial of x. The power xy raises the value of x to the power of y. The math pi gives the value of the pi constant, and the sine functions work with radians. Now I expect you know that the what radians is. So this is all about the math module. Next, the statistics module. It provides tools for analyzing numerical data, or it gives me a statistical analysis of my data. So you can calculate mean, median, mode, variance, standard deviation directly just from a list. So for instance, here I have taken a list data and I have some values in it. Now I am importing statistics as stats. My statistics is the module which I am importing as stats. Now here I want the stats, uh, I want the mean of my data, median of my data, mode, variance, and standard deviation. So these are the functions that I'm going to use, and when I run it, I get these values. So the mean of my list would be this, median this, mode 40, variance, and standard deviation. So the explanation is mean gives you the average value of the list. So when I get the average value of the list, it becomes my mean. So I didn't have to hard code how to find the average value of the list. I didn't have to sum all of these and divide it by the total number. I can easily get the mean value by just this, for this simple mean function, which is in the statistics module. Median is the middle value stored data. Mode is the most frequently occurring value. Variance is the spread of the data from mean, and standard deviation measures the dispersion. Now that we know that we can do data analysis part with these modules these functions present in the statistics module. Now moving on to the decimal module. So decimal module is basically used for high precision arithmetic tasks. So it is very perfect for money calculations or any financial issues. So when there are floating point errors, it can easily tackle with it. Okay. So I'm just importing two functions, that is decimal and get context, from the decimal module, and I'm going to use it here. Now, what I'm seeing here, that decimal, this a is equal to decimal and this b is equal to decimal functions creates a very high precision number. Now, whatever I give it, it will create, like see, get constant prec function will give, where I have put 6, it will give me a very high precision number. So here the precision is set to 6 digits. That means my whatever operation I will do, it will give me a digit, 6 digits after the decimal. So here I have taken A and B values as decimal values. I have converted the strings as decimal values, and now I'm going to add, multiply, and divide these values. So my precision is 6. That means that I can get up to 6 values after the operation. So you can see after the decimal, we have 6 digits only. So this is the precision. Now you can see the decimal converts this string to precise decimal representation, and get context actually sets the decimal precision. Now we can perform the operations with minimal rounding error. So let's just see the workflow once. That first we have to identify the task, that whatever task we are going to do. If I need to use the math module or the statistics module or the decimal precision, we need to know our task. So depending on our task, Python provides various modules that we can easily use. So after that, we are going to import the respective module that we need to perform the task. So from the module, now we can import some functions or use the desired functions that we need for our operations. So like here for decimal, we are setting precision using the getContext.prec function. Now, later on, we can just print the required results. So for best practices, use math for standard mathematical operations. That will save your time and it will make your calculations more efficient. Use statistics for data analysis without needing external libraries. You can just have the module in it. And then we can use decimal for the accuracy is critical. Whenever I need the precision and accuracy to be critical, we should use the decimal module. Now, there is one thing you need to keep in mind, that trigonometric functions use radians. We can't just give degrees like 90 degrees. I want the sine value of the 90 degree. We have to provide radians. Now, this is how we import the modules in our program. So that's it for today. You now know how to use the math, statistics, and decimal modules. Now you have your task figured out, that what you want to do, what operations you want. Then you go to these modules, maybe go to the documentation of the module, so you can find more of the functions and many functions for complex calculations or analysis, so that you can use those functions in your Python program. Thank you so much.